So 2 plus 2 is 4, 50 minus 9 is 41, 25 times 2 is 50, 25 divided by 5 is 5.0. What is this? 5 2 star 2? Yeah, 5 to the power 2, right? So you can raise any power. And this is the regular division that we have in Python. It's 5 by 2. This is a regular division. It's going to give you a float. And we'll talk about some of these variables a little bit later on. This is a modulus division. What do you think the modulus division do? So if you look at the output, modulus is going to give you 1 and floor is going to give you 2. So now tell me what is happening. Multiple, right? So you're dividing 5 by 2. So it will go 2 times completely, and that's what you're getting in the floor. So whatever is a multiple, that is going to come out in the floor, and whatever is the remainder, that is going to be the output from the modulus division. Where would we use it? Is it just for the mathematical gyan, or can we use it somewhere? So there is a regular division, Shinu. So this will give you the float right over here. Then there's a modulus division which will give you the remainder. There's a floor division which will give you the multiple. So my question is, why we need so many divisions? What is the utility? What could be the utility? So let's say you are trying to find out the prime numbers, or you're trying to find out the multiples of 3 or multiples of 7 and so on and so forth. You can actually run some of these criteria to really figure out how many times it's going, right? So if the remainder comes out to be, if you do a modulus division and there's a 0 remainder, that means it's a multiple of that, right? So let's say you're testing for the 7's multiple, right? And there's a big number. And you want to quickly test out whether that is fully divisible by 7 or not. You can do a modulus division and see if the remainder is 0. Then it is basically a full multiple of 7, right? Similarly, the prime number that we want to test. All right, so everyone is with me? We're good? Okay, so that's one thing. So there are, basically you can do bunch of arithmetic operations, no issues at all. Then we're going to do the relational operations. What are the relational operations? So before we go to the relational operation, if you want to assign a value, so for example, if I want to make x is equal to 2, I will use the x single equal sign, and that's the assignment, right? This is the assignment operator. Just like in R you have the equal, and R you also have this arrow thing. Over here it will be the equal sign. You are making x is equal to 2. When you have double equal sign, you are testing for the equality, right? Is that point clear, everyone? The differentiation between single equal and double equal? Double equal is you're asking Python, is 1 equal to 2? Python comes back and says false. It is not. 1 is not equal to 2, right? Similarly, I can go and say, is 1 equal to 1? So what do you think will be the answer? It will be true, right? So these are the things that we're looking at. Let me try to fit on the window, right? So 1 is equal to 2 is false. 1 equal to 1 is true. Is 1 less than or equal to 2? Yes. Is 1 not equal to 2? Is 2 greater than 1? Right? So that's the output. So go ahead and try it. Just type some of them, at least practice some of them, so that you know it's working out for you. And these true false values, what types of values these are? These are the Boolean, right? So you can assign to the unknown variables or the objects, but you cannot assign to, right? Yeah. Double equal sign. Fourth one is not, hyphen, is not equal to 2. So you're testing, is 1 not equal to 2? So it should come back and say true. These are the logical comparisons we are making. So are you saying, is 1 equal to 2? Is 1 equal to 1? Is 1 is equal to less than equal to 2? And 1 is not equal to 2? Hyphen. So it's basically this symbol. I mean, you'll find on your keyboard somewhere. It's this symbol, Shinu.
What is the logic? So what is it returning?
You're testing, is 1 equal to 2? So the output is going to be the logical result of that.
Okay.
So the test is, you're asking Python,
okay,
can you please confirm, is 1 equal to 2?
Okay.
It will come back and answer in only 2 ways,
Okay.
true or false.
True or false.
Yeah.
If it is 1 equal symbol, then it is an assignment.
Then 1 is being assigned to something. So you can do x is equal to 1. So that means x is going to hold the value of 1. We'll be doing that a little bit later on. But these are some of the basic building blocks. Is everyone with me? Anyone who is confused? Yes, exactly. So you can actually, the point Kavita raised is absolutely valid. So let's say you have two different arrays, array X and array Y, and you're gonna say, is array X equal to array Y? It will come back and say yes or no, right? So it's just basically, using the simple math over here, but the equality is applicable across the objects that we have in Python, right? All right. Shall we move on? Yes? Perfect. So let's keep going. And then what we're going to do is this. Now I would like you to tell me run the code and tell me the answers for each one of them. What do you think is happening over here? Yeah. So the first is 1 equal sign. So what is going to be the value of X? X is going to be 2. Y is going to be 5. Then we're going to do some logical testing over here. So you tell me what is going to be the answer for each one of them. Let's see. And I will ask every one of you one by one. So let's see who can tell me for the first one. Raise your hand when you have the answer for the first one. This one. What will be the answer for this? No, run the code. Not just looking at this. You have run the code? So the answer there is true, right? So let's make sure that everybody is able to keep pace with this. So it's going to test for two things. So first thing it's going to test for is X is equal to 2 and Y is equal to 5. And indeed that is the case. Both conditions are met. So the answer will be true. Make sure that you are able to get this result. Okay. So what is the second one testing? Yeah. Is it false? Are you sure? No, but are you sure it's going to be true or false?
It is false.
This one? Yeah, that's what I'm saying. So it's saying either X is equal to 2 or Y is equal to 7. The answer is going to be true because X is equal to 2. The third will be the false one, Bonnie, to your point, because this condition is met, but this condition is not met. Sorry, this one. So and is going to be the false. Not. So that is X is not equal to 2 or Y is not equal to 0. What do you think is going to be the answer for this? Yes, the correct answer is true on this one. So X is not equal to true, that condition is not met, but Y is not equal to 0, that condition is met, so the answer is going to be true. Is that clear? Okay, perfect. Nice. This X is not equal to true, so this condition is not met because X is indeed equal to true, and Y is not equal to 0. So even I don't have to look at the second condition because this condition itself fails, so I can know that this is going to be a false, right? Then X is equal to X, X is equal to Y, Y is equal to Y. Who can tell me? This is true. This is false, this is true. If I do X is equal to Y, what will be the answer for that? No, no, think again. If I'm saying if X is equal to 2, so what will be the value of X and what will be the value of Y? X will be 5, Y will be 5. Clear? Everybody is clear? Because I'm assigning the value of Y to X, so X value of 2 will be overwritten by the Y value, so X will become 5 and Y will continue to be 5. Clear? It's very important that you pay attention to this because that's how Python can trick you sometimes, right? Yeah, it is very similar to R only. So if you know R, you can, see, once you know any coding language, picking up another language takes hardly a week, not more than that. Yeah, hardly a week's time. So, you should not be worried, what the heck, man, I spent so much time learning R, now here this guy is and talking about Python and so on and so forth. It will be just 1 week's job for you. So it's not going to take anything more than that, right? So X is equal to 2 is, so you're getting the answers over here as we expected, right? Now this is interesting, so I'll give you guys time to do it and then come back and tell me the answers for each one of them. So remember, this is not the logical testing, but this is the assignment that is happening. So we are assigning a value of 2 to x and 5 to y, and then we're going to do these operations. And you tell me what these operations are and what should be the value. Let's see who can answer each one of them by running the code. Or if you don't have to run, your mind works faster than the computer, you can tell me. Which one? This is x minus, this is x plus, this is x star, x divided, x to the power y, x modulus, x floor. No, the cap, I mean, I'm not sure whether that exists over here. So 2 stars is basically what we use. Yeah. The floor, this is the floor, this is the modulus, the floor. So try it out and then it will make sense to you what exactly is the output. So now you know why I'm not giving you the code, otherwise you can directly copy paste and run it, and you will miss out the syntax on how exactly things really work out. So let's look at the output here. Everybody's done? Okay, so x plus y is going to be straightforward, and I will use my screen over here. So x plus y is 7, very clear. X minus 5 is minus 3, clear, right? X to the power, x times y is 2 times 5, which is basically, where is that? Yeah, over here, right? X divided by y, which is 2 by 5, is basically 0.4, which is over here, right? So far so good? Okay, now let's go to a little bit tricky ones, which is x to the power y. So it's basically nothing but x to the power y or x to the power y in this terminology. So that's 2 to the power 5, right? So that's 32. Make sense? Now x modulo y is what? Remainder, because 5 cannot divide 2. So the remainder is 2. 5 cannot go even once in that. So the remainder is going to be 2. So if it was 7, you will still get 2. 7 divided by 5 is still going to be 2. You see that? Because 5 goes in 7 once and the remainder is going to be 2. Right? So and then floor is going to be how much? 0, because it cannot go even once, right? So that's the thought behind that. Okay, now let's look at this. This is going to be interesting. So augmented assignment. So right now we said, okay, x is equal to y plus 1 or x is equal to y plus 2. We can do both things in short, right? So what does it really mean is that a is going to be a plus b, a is going to be a minus b, a is going to be a times b, and so on and so forth, right? So you can do two things in shorthand basically. That brings in more efficiency. It's called augmented assignment. So you're assigning and conducting some mathematical operations.
How do you actually do this? A plus equals B.
Yeah.
Is it like A?
A is equal to a plus b.
Okay.
That's how the comment that says a is equal to a plus b. So basically it's gonna apply the same function on this, right? So and then a is equal to a minus b. Yeah. A is equal to a times b. A is equal to a by b. So on and so forth.
A is equal to A plus B.
Right. Same thing. Yeah. But I mean, you are actually saving a little bit of the thing. So you're typing A only once, right? And it will make a difference when you have the bigger names and stuff like that. I mean, you don't have to type the whole thing. I mean, right now it's just very simple. But that's called the augmented assignments. Okay. So what it's doing is basically A is equal to 5, B is equal to 7. Then we are saying A is equal to A plus B. So remember there's a plus sign here and then assignment. So we are actually saying A is going to be A plus B. And then I'm printing the A. What is going to be the value of A? So that comes out to be 12. So A is going to be A plus B is 12, right? In the next one I'm saying A is going to be A minus B. Then I'm printing the value of A again. So what was the A over here? 12, right? So make sure that you're not going back to the same value of A, because now the A becomes 12. So when you do A is equal to A minus B, that's 12 minus 7, which becomes 5. Clear? Okay. A is overwritten. The value of A is overwritten with this one. Yeah. Huh?
The value of A is overwritten as A is equal to A minus B.
No. So once you run this, A becomes 12. A is no longer 5, B continues to be 7. Then you come over here, so is 12 minus 7, which becomes 5. Then you come over here, this will be 5 times 7, 35. And A is 5 again. Then you come over here, that's going to be 5 divided by 7, and so on and so forth, right? It's the multiple, how many times that is going to divide there. So if you are doing, it's the modulus, it's the remainder, right? So what you're looking at is how many, what is going to be the remainder when you divide something. So 5 divided by 2 is 1, because 2 2s are 4, so 1 is the remainder. So the remainder is coming out to be 1. 7 cannot divide 5, so remainder is 0. It cannot divide even once, so that's why the remainder is 0. So another thing about the Python is that it's very, very particular about the indent that you're using, right? So don't move things unnecessarily here and there. So if you move like this, it will assume that this is a block of code that you're going to execute, right? So I'll talk about that a little bit later, right? So it's very, very sensitive to the indent that you have in the code. So that's why I'm starting on the first line itself, right? So if I move it, let's say like this, and then run it, in this case it's giving me fine, but sorry, where is it?
It's above.
Yeah, there you go, right? So it's actually giving me the unexpected indent, because it was not expecting these spaces to be over here, right? So make sure that you do not do that. No, in R it doesn't matter, but over here it simplifies your job. It's not a trick. It simplifies. I mean, you'll see it as you move forward. When we're running the loops and while loops, for loops, all of those, it will be, knowing this is a block of code that you're actually executing, right? So it will be coming handy later on. Right now it seems like pain. So that it will be expecting this entire code has to be run together. This is a block of code that I have to run, right? So that is the reason. So once I move the indent back, then we are good to go, right? So now it's printing everything fine. Okay? So now this one everybody has done. Shall I explain what is happening over here? Or everybody is clear? So let me see if I can explain few of them, the tricky ones. So I think, you guys got that concept which is the most tricky, which is A does not remain A. So once you change that, it's going to be the value of A is going to be overwritten, right? And when we are running the for loop, there'll be the local and global variables as well, right? So if you define an X variable within a loop, this X is valid within the loop only. There is another X outside which may have a different value. The moment you come out of the loop, that will become the global value of X. Within the loop, it will be the local value of X that we're looking at. No, right now it's a global value. But I'm saying you can have an A which is executed within a loop, so that A could be different. The moment you come out, again A becomes this, because right now it's all global values that we're dealing with, right? It will be overwritten in the global values, right? So I think this is where A becomes 12, that's what the output is. Then 12 minus 7 is 5. And then what is the value of A? A continues to be 5, B continues to be 7 now, and then 35, and then A times, sorry, over here, right? Yeah, 35 divided by 7 is 5, right? And so on and so forth, right?